Alright, hi guys, hope it's all going well. This is our second lesson on geometry that we're looking at in congruency. Let's just get stuck in. So, what I would like you to do is hit pause on this video and in 4 minutes see if you can answer as many of these questions as possible. I'll quickly go through the answers in about 5 seconds from now. So pause this, give them a go. Okay, assuming that you paused the video and gave it a go, hopefully you got the answers of, let me remove it, 343 centimeters cubed. So to figure that out, a cube with the side length of 7 centimeters is just 7 times 7 times 7, which is, or just 7 cubed, which is where that expression comes from. We'll give you 343. Simplify this fraction, 45 over 18. I know that 9 goes into both of those. That's 5 over 2, which should roughly be 2.5. 6 over 8 minus 3 over 5. If you times both sides by the denominators, you should get 30 over 40 and 24 over 40, which is 6 over 40. You can simplify that down to 3 over 20. Next one, 5 times 9 is 45. 18 times 25 is something big. 450, I think, ish. I'm assuming I think it's 450. 45 over 450 cancels down to 1 over 10. Convert 2034 to 12-hour time. The 2034 is 20 hours past and 34 minutes. So if you want to convert that to 12-hour time, you just need to subtract 12 hours off that. So if you've got a 24-hour clock at home, you probably know how to do this already, but essentially it's 8 hours, 34 minutes, or 8:34 p.m. Finally, a rectangle has a perimeter of 10 and an area of 6. What are the side lengths? I was hoping that might be a bit of a challenge, but essentially you're looking at two numbers that plus together and then plus together again to make 10 to represent the 4 sides of a rectangle, but then multiply to make 6. Realistically, because there's 2 sides, or 2 of each number on the sides of a rectangle, we're thinking rather than doing side A plus side B plus side A plus side B equals 10, which is 2A plus 2B equals 10, you can just say, let's just half that whole thing, and we'll just say the 2 side lengths plus together make 5, and the area times together makes 6, so the numbers have to be 2 and 3. A little bit hard to explain verbally, but if you try writing it down, you'll start to get the right idea. Alright, so here, what I want you to do is pause the video and see in a minute if you could write a description of this triangle to somebody who couldn't see it. Do you reckon they'd be able to figure out roughly what this triangle looks like? So pause the video for a minute, quickly describe each triangle, and see if you think you can describe them accurately. So pause it now. Okay, so assuming that you paused that video, here are some of the things that you could see. You could say the first triangle has got 2 acute angles and 2 side lengths that are the same, and it's an isosceles triangle. You could say that all 3 angles and all 3 sides are the same, or it's an equilateral triangle. And then the last one, you could say that there's an obtuse angle with 3 side lengths all being different and all 3 angles being different, or a scalene triangle, if you haven't heard of those before. Alright, so going on to congruency, we talked about this last time. Congruent means same size, same shape. We also talked about if you could test for congruency and writing out a testing statement. Well, there are rules that test for congruency, and we're going to talk about them today. So you have to be able to prove that 2 shapes are the same. So how do we do that? Okay, here are the 5 rules. So you can prove that two triangles are the same if, rule 1, all three sides are the same length. Rule 2, two sides with an angle in between them are the same in both triangles. Rule 3, two angles with a side in between them are the same in both triangles. Rule 4, two angles and another side are the same in both triangles. And rule number 5, they're both right angles. The hypotenuse is the same in both, and another side in the triangle is the same in both. So I'd recommend you write them down. We're going to go through a few of them now, and then you can give it a go. So, right, rule number 1, side, side, side. Basically, if you want to say that these two triangles are congruent, you have to explain that you're using the rule side, 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 and essentially do what we've done here. So to check that these two are congruent, each side has to be matching a corresponding side. Now, in all these diagrams, what you see is these little lines. So one line matches one line, 2 matches 2, 3 matches 3. In an actual example, you're going to be looking at real numbers that might be 4, 5, 6 or something like that. So the side A to B is the same as the side E to D. They've both got that one tick, so we know that's true. B to C is the same as E to F. B to C, E to F, both the same. A to C is the same as D, F. A to C, D to F. Right? You can see that they're all the same. Therefore, they are the same triangle, just on a different angle. Here's side, angle, side, so you get an idea of what that looks like. Again, angle, side A to B. This is an error, sorry, ignore that. It's supposed to be side B to B. It's equal to side E to D. Never mind, ignore that, I'm just making mistakes. So C to B is the same as E to D. You can tell because they both have that line. A to C here is the same as E to F. They both have the double line. And angle C and angle E are the same as well. Alright, this one, get rid of that now. Angle, side, angle, which is similar to angle, angle, side. They're basically the same thing. Alright, when a pair of corresponding angles and the side in between them are equal. So, angle B and angle E are the same. They've both got that one little line through. Angle C is equal to angle F. They've both got double lines. And similar with the sides before, when you actually look at real examples, it might be 45 degrees and 60 degrees. They'll actually have values, not just lines. This is just a demonstration. And then lastly, B to C is the same as E to F. So therefore, we can say angle, side, angle is accurate in this case. Alright, now what I want you to do, again, pause the video and see if you can figure out what test you would use on these three triangles. And then I'll tell you in a second what they were and you check if you're right or wrong. Pause it now and give it a go. Okay, so assuming that you've paused that, I'm just going to put in a little text box here, if I can. Text box. Okay, so first one, I can see that E to D is the same as, and I've forgotten how to do this one here. I'll show you the symbol. Where's congruency? I'm looking for the little cake looking thing. There it is. Alright. So E to D is the same as N to N. I'm just going to copy this symbol so I don't have to paste it again. So E to d is the same as m to n. We have m to, we've got to keep it consistent on the same side. E to f is the same as m to l. And then lastly, d to f is congruent with n to l. Right? Cool. So if you want to add on to that, you can sort of say therefore, triangle BEF is congruent to triangle LMN. Right. Cool. That was side. I'm just going to copy paste this and change it slightly. Now this one, you haven't guessed already. Whoop. Where did I go? If you haven't guessed already, it was side angle side. So I'm going to start with sides. BF is the same as QB. AF, AF is the same as Q.